All right, so here's another not super complicated example, so we can kind of get used to it. All right, a 0.25 kilogram block slides down a ramp, starting from rest. About 20% of the energy ends up stored as thermal energy due to friction. Find the speed of the block when it slid down the 2 meter tall ramp. Okay, so they're telling us here that this is 2 meters. Okay, oftentimes they don't tell you that, right? They'll give you like the length and the angle, and then you have to solve for that. Okay, so just be careful. If they give you the ramp length, that's not what you want. You actually need the height of the ramp. Okay, but this one gives it to you. Okay, all right, so we're looking at the cart, the ramp, and the earth. All right, and we want to start with gravitational potential energy when it's sitting at the top of the ramp and it's at rest and there's no springs. Okay, and then by the time it gets to the bottom of the ramp, oops, all right, it's going to be moving faster. Okay, no UG, no US, but we are going to have some thermal, right? So we're not going to be able to have 4 bars of kinetic. There's going to have to be some lesser amount. Okay, and yes, I know that's 25%, but whatever. That'll be 20% of it. Okay, all right. So when I write my equation, I'm going to put UG equals K plus E therm. Okay, and there's a couple different ways you can do it. You can either figure out what this number is first, right, the total energy, and then take 20% of it to put in for E therm, okay? Or another way you can think of it, right, is if I have my initial and my final, I'm only really getting 0.8 of my initial, okay, right? Because only 80% of what I have here is going to end up in the kinetic column, all right? So if you want to do it like that, that's fine too. It doesn't really matter. You know, in this case, it's pretty simple because you know everything, so it doesn't matter either way. Okay, so I'm going to next line down. I'm going to write my equations. Okay, and don't skip this step because there might be a point on the AP test for writing it. Okay, so mgh equals 1/2 mv squared plus the thermal. Okay, my mass is 0.25 times 10 times a height of 2. Okay, which comes out to be 5 joules, okay? And 20% of 5 is 1, so that's how I'm going to put a 1 right here, okay? mv final squared plus 1, okay? 1/2 mv final squared plus 1. So you see if I subtract this over 4 joules over here, right, that would have been the same as doing 0.8 of the original, okay, over there. So that's fine. Okay, so 4 joules is 1/2 0.25 BF squared, okay, and then I'm sure you can crank this math out. 4.125 equals radical 32 is 5.7 meters per second. Okay.